Okay, so let's solve the following question circuit here. So we're told the S of t is 10 times unit step function, and we're told the initial condition of the current flowing through the inductor is minus 1 amp, and we're also told the initial condition of the voltage at the capacitor is 5 volts. Okay, so now let's get everything into Laplace format. So for this, the Laplace of 10 times the unit step function will be 10 over s. For the resistance, it's just 10 over 3, so it's still just a resistance value. Now, the other two, since the initial condition is not 0, it's like minus 1 and 5, we'll have to like kind of work in a different way. So we know I of t is equal to the inductance, V of t is equal to the inductance times the change in current over the change in time. So if you take the Laplace of this turns into Vs, and then this turns into Si and minus the initial condition of 0. Okay, so that means this is supposed to be minus 1 amp. Okay, so now we will have to pretty much replace this portion of the circuit with one of two wires. So we can either replace it with the following. We can include a voltage source like this, and its voltage will be minus 1 times the inductance value, because if we foil this throughout into our thing, so CVS has is also dependent on minus 1 times L. So this minus 1 times L. So that means the voltage source, we can replace this with a voltage source like this, or we can instead replace it with a current source. So the current source will be in parallel with the inductor. Okay, and to get the value of this current source here, we will have to isolate for I of s. So this turns into the following. So this and this cancels out. So we pretty much use this value to represent our current source. So minus 1 over s. Okay? So this is what we're going to work with. Okay? You can choose the voltage source if you want to, but I'm going to choose this one instead. And so that means for this, we will replace this with minus 1 over s. And then the Laplace of the inductance, it's going to be s times L. So L being 5 henries, so it'll be 5s. Okay, now let's do the capacitor. So we know the current passing through a capacitor is equal to the capacitance times the change in voltage over the change in time. After we get the Laplace for this is I of s. This is equal to C times S times Vs minus the initial condition of V at 0. So we know what this is supposed to be. This will be 5 volts. So this is 5 volts here. And we can now either do one of two. We can put the capacitor. So we're pretty much going to replace this with one of two. So we can add like a voltage source like this, and or we can add like a current source. Okay, let's go with using a voltage source. Okay, so that means we will have to isolate for V of S. So what we'll do is boil out the C. Okay, let's bring the C to the other side and divide everything by SC, and that'll be your V of S. So this is SC is equal to 5 over S, and sorry, it's plus 5 over S, and that's equal to Vs. So this is going to be representing the voltage here, so 5 over S. And for this, it's pretty much 1 over SC, where C is your capacitance, which is 0.1. So 1 over 0.1, and that's just 10 over S. Okay, so we have 10 over S here, and we're just going to replace this with 5 over S. Alright, so let's take the circuit and now try and solve for it. This is 10 over S, 10 over 3 ohms. So this is 5S. This is minus 1 over S. This is 10 over S. This is 5 over S. Alright, so we have this circuit here, and we're trying to find the voltage. Wait, let me see what we're trying to actually solve for. Okay, so we have to find the voltage passing through this capacitor. So it's pretty much just going to be the voltage here. So this is what we're going to do. We're going to set the point here to be V1. So we'll have a current passing through here. We're going to call this I. Actually, we're not going to really call it anything, but we'll have a current passing through here and a current passing through here. So it's going to be V1 minus 10 over S all over 10 over 3 plus V1 over 5S minus this current, so minus 1 over S, plus V1 minus 5 over S all over 10 over S. So this part, it turns into 3 over 10 V1 minus 3 over S plus V1 over 5 times S minus 1 over S. And then this, it turns into what should this turn into? Oh, so okay, so I'm gonna look. Okay, so it should be S V1 over 10 minus 5 over 10. So yeah, that looks pretty good. So now let's collect like terms. So we have V1, so 3 over 10 plus 1 over 5S plus S over 10. And we'll bring all of these to the other side. So it'll be equal to 3 over S plus 1 over S plus 5 over 10, which is pretty much just 1 over 2. Okay, so next thing we'll do is times everything by S. So we'll times this by S and S. This by S is S and S. and we'll times this by 2. Now we have 3s plus 2 plus, this should be 5s, right? Okay. Oh, no, sorry. It should be s squared, because this is not a 5, this is an s. Sorry. So it'll be s squared all over 10s. And this will be equal to 3 over s plus 1 over s, which is just 4 over s, plus 1 over 2. Okay? So these two are both s's. Sorry, I thought it was a 5s. Never mind. It was a s times s, which is just s squared. Okay, so what should we do next? Let's times everything by 10s. So this gets cancelled out. So we have v1, 3s plus 2 plus s squared is equal to 40 plus 5s. Okay, and now let's isolate for this v1 here. So it'll be equal to 40 plus 5s all over s squared plus 3s plus 2. Okay, now we can just factor the bottom part. So that will be s plus 2, s plus 1. And now what we can do furthermore is break this up into two pieces. Okay, and this v1 is actually v1 of s. So we have to get the inverse Laplace to get v1 of t. Okay, so we will do two inverse Laplaces. So inverse Laplace of 40 all over s plus 2 times s plus 1 plus inverse Laplace of 5s all over s plus 2 times s plus 1. So we'll have to do partial fractions. So let's do the partial fractions for this one. So it'll be 40 all over s plus 2 times s plus 1. That will be equal to a all over s plus 2 plus b all over s plus 1 times everything by this value. So we have 40 equals a s plus 1 plus b s plus 2. Now when we let s equal minus 2, our a should be minus 40. And when we let s to be minus 1, our b should be 40. So our partial fractions should be minus 40 all over s plus 2 plus 40 all over s plus 1. So that's the first part done. Now let's do the second part, which is this part. So we have 5s all over s plus 2 times s plus 1. That's equal to a all over s plus 2 plus b all over s plus 1 times everything by this value. So we have 5s is equal to a s plus 1 plus b s plus 2. So if we let s to be minus 1, our b should be minus 5. And when we let s to be minus 2, our a should be 10. So this one will be 10 over s plus 2 minus 5 over s plus 1. Okay, now we just combine both of these because they're technically supposed to be added up, and we just get the Laplace of all of these. So we have minus 40 all over s plus 2 plus 40 all over s plus 1 plus 10 all over s plus 2 minus 5 all over s plus 1. And getting the inverse Laplace of this should be minus 40 e to the power of minus 2t this one should be plus 40 e to the power of minus t. This one should be 10 times e to the power of minus 2t, and this one should be minus 5 e to the power of minus t, and that's just minus 30 e to the power of minus 2t plus 35 e to the power of minus t. Okay, and that's pretty much your final value. This is for the voltage across the capacitor, and this is for when t is greater than or equal to 0.